Welcome to Biology My Passion. I am Soumya Harikrishna. We have been learning the chapter Light Reflection and Refraction. We learned the reflection part in the previous videos, and also we discussed certain questions related to this reflection and a few questions from refraction already. So now we are going to learn the second part of this chapter, that is refraction. What is meant by refraction? Refraction is the phenomenon of bending in the path of light as it travels from one medium to another. See, we saw that suppose there is an opaque medium, the light falling at an oblique angle will reflect with the same angle. So this is the reflection process. But if the medium is transparent, the light falling on it will pass through it. But when it is passing through it, it will slightly bend from its actual path. This bending of light rays when it is traveling from one medium, for example, this is first medium, medium 1, it is entering into another medium. Imagine you are looking through a glass. So air is the first medium and you are looking through a glass is the second medium. So when light is entering from one medium to the other, there is a slight bending of the path of light, that is called a refraction. Now, what is the reason for this refraction? So, there is a property for the transparent medium that is called the optical density. We are all familiar with the mass density, but this is different. This is related to optics or light. Means how it is allowing the light to pass through is measured in terms of optical density. So there are two types of media. One is the one having higher optical density, then we call it as denser medium. The other one is the lower the optical density, then we call it as rarer medium. Suppose if the optical density is high or the denser medium, the velocity of light is very low. Because if the medium is optically denser, it will not allow the light to pass through easily, so the velocity decreases. Whereas if it is a rarer medium or optically rarer medium, light can pass through very easily, so the velocity of light will be very high. This you have to remember, optically denser medium and optically rarer medium. We know that optically denser medium will decrease the velocity of light, whereas through a rarer medium light can pass very fast. Suppose when it is moving from a denser medium to a rarer medium. Suppose this is medium 1 and this is medium 2. Imagine this is a rarer medium, for example air, or this is a medium called glass, which is optically denser than the rarer one or air. So here is the normal. So when an incident ray is falling on it, and if it is going from rarer to denser, the refracted ray is supposed to go straight like this. In this case, when it is moving from rarer medium to denser medium, since its velocity is decreasing, it will bend towards the normal. So rarer to denser, if it is moving, it will move towards the normal. Hope you know what is normal. Normal is the perpendicular drawn to that point of incidence, or the refracted plane. Now in the second case, again I am drawing a normal here. This is the incident ray, but this time this is the denser medium. It is going to a rarer medium. So it is supposed to go this way straight, but since it is going from denser to rarer, it will move away from the normal. That is supposed to go like this, but it is moving little away from that. So angle of refraction is this, and this is called denser to rarer, so away from the normal. Okay, so this you have to remember always. When the light is going from rarer medium to denser medium, it will move towards the normal. When it is going from denser medium to rarer medium, it will go away from the normal. So here we can say that angle of incident angle is greater than the angle of refraction. Whereas in this case, angle of incidence is less than angle of refraction. Here is a plane through which light is traveling. So there is a perpendicular line drawn through it. This is called the normal. Normal means perpendicular to the surface. Now a ray is falling onto it. This ray is called the incident ray. Now the ray will pass through the second medium but with a bend. So this is called the refracted ray. The angle made between the incident ray and the normal is called the angle of incidence, whereas the angle made between the refracted ray and the normal is called the angle of refraction. So this is the incident plane or the surface, and here is the point of incidence. So this ray which is falling is called incident ray. The ray which is passing through the second medium is called the refracted ray, which will have a bend in its direction, and there is a point of incidence, that's the incident plane, and there is normal which is perpendicular line to the surface. Now we will see the rules of refraction, that means laws of refraction. Hope you remember the laws of reflection. The first law is same for both, that is the incident ray, normal, and the refracted ray. There it was reflected ray, now it is refracted ray, all lie in the same plane. So first rule is same for both, whereas the second law here is the angle of incidence and the angle of reflection are same, we learned in the previous one. Here sine of angle of incidence to sine of angle of refraction is a constant. Suppose through the same medium, if you keep changing the incident ray angle, then the angle of refraction also will change. So it will remain constant in the same medium. So we can write this as sin I by sin R, that is sine of angle of incidence to sine of angle of refraction is equal to a constant. This law is otherwise called a Snell's law. After write the Snell's law, you have to write only the second law of refraction, not both. Okay, first law is all is in the same plane, that is incident ray, refracted ray and the normal. That is the first law, but second law is only called a Snell's law. Now we have to think about the movement of light or the refraction of light through a glass slab. Okay, here you can see a glass slab which is a thick glass rectangular shaped glass piece. So here we are seeing how the light can pass through it, how it is getting refracted. So we know that the first medium from where the light is coming is air and the second medium is glass. So always air is an optically rarer medium, glass is an optically denser medium. Now let us see how the incident ray is falling on it obliquely to the normal. So here is our ray of incidence, that is incident ray. It is making an angle with the normal, which is called an angle of incidence. So now we are expecting it to go straight in this path, but since it is coming from rarer to denser medium, it will bend towards the normal. Instead of going straight, it will be going this way. So this ray is called the refracted ray. This is the incident ray, and between the normal and the refracted ray is the angle of refraction. Now here is another point of incidence. Here it is going from glass, which is a denser medium, to air, which is a rarer medium. So in this case, now what happens? This is the perpendicular at the point of incidence, that is called the normal. It is going from denser to rarer, it will move away from the normal. So it was supposed to go straight like this. So this ray is the emergent ray. And this angle between the normal and the emergent ray is called the angle of emergence. So here is the incident ray. Since it is moving from rarer medium to denser medium, it is moving towards the normal, and at the next point of incidence, where it is moving out of the glass, it is going from a denser medium to a rarer medium. So it is moving away from the normal, making an angle with the normal called the emergent angle or angle of emergence. So this ray, suppose if it was not entering into the glass, it would have gone straight like this. Alright, so it was supposed to go this way straight, but now it is coming out from here. So there was a perpendicular shift from the actual path to the new emergent path. So this is called a lateral displacement. So here the emergent ray is laterally displaced from the actual. Actually, we produce the incident ray forward. It was supposed to be the path if there was no glass, but emergent ray. So the distance between the incident ray produced forward and the emergent ray we can call as the lateral displacement. Now, if what are the factors on which the lateral displacement depends? First of all, when there is the angle of incidence increases, then lateral displacement also will increase. Then the refractive index of glass if increases, then also lateral displacement will increase. I will teach you about the refractive index. So this diagram you have to practice well. It is an important concept for your examination. Now we will discuss the refraction through a prism. So prism, as you are seeing in the picture, it is in the three-dimensional view you are seeing in this picture. Okay, so it has got a 5 surfaces, and the lateral surfaces are refracting the light. Suppose the light is falling here. This is the incident light. We will draw a normal here to the plane of incidence. If there was no glass, this was supposed to go straight. But since it is going from air to glass, which is a rarer medium, it bends towards the normal. Actually, it was supposed to go this way, but now it has refracted and bent towards the normal. Now another plane, normal is at the plane, and now it is coming out of the glass, that is from denser to rarer. So it was supposed to go again in the direct path, but it is bending towards the normal. So it is going in this path. So if you produce the incident ray, this is the incident ray, and this is the refracted, here is the refracted ray, this is the emergent ray. Now we know that if you produce this backwards, this incident ray produced forward and the emergent ray produced backward will meet at an angle. This is called the angle of deviation. So angle of deviation is the angle produced when we produce incident ray forward and the emergent ray backwards. That means it is showing how much the light is bent. It was supposed to go this way, but it bent at an angle this much, that is called the angle of deviation. So how much it is bending is shown by angle of deviation. Now we will talk about a concept of refractive index. So refractive index is a very important concept. You have to understand it very clearly. Some way it can be measured using two symbols. Either we can use mu, which is a Greek symbol, or we use small letter n. In your textbook n is used, so we will be using n. So here is a plane, and this is the normal to the plane. Now there is an incident ray falling on it obliquely, making an angle of incidence. So if it is going from a rarer medium to denser medium, we know that it bent towards the normal. Okay, so here we know that there is a change in the velocity of light, that is rarer medium. In the rarer medium, velocity is very high. This is denser medium, so velocity is less, decreasing. Okay, so this is the first medium. I am taking the refractive index of the first medium as N1 and the second medium as N2. Whereas velocity I am taking the first medium as V1 and second medium as V2. Now listen very carefully. Refractive index is a measure of optical density. So when optical density is high, refractive index is also high. Optical density is less, refractive index is also less. Refractive index is the ratio of the speed of light in a pair of media. Refractive index we can consider in two ways. One is called the absolute refractive index. Absolute refractive index means, suppose the first medium is air and the second medium is some other medium with a higher refractive index. Why? Because air has the least refractive index. As a result, light will travel at its maximum speed of 3 into 10 to the power of meter per second. Whereas any medium it enters from air. In the case of air, we can consider vacuum also, because air and vacuum almost the same. So air or vacuum has got the least optical density. As a result, light travels the fastest through it, and the highest velocity of light is 3 into 10 to the power of 8 meter per second. This is the speed of light, usually we say, and you have to by heart this value. Now the medium too, it can be any medium with a considerable refractive index. For example, if it is, it can be water or glass or kerosene or a diamond, but diamond has the maximum refractive index, whereas air has the least refractive index. So any other medium it is entering into, then if one medium is air, its velocity will definitely decrease. So that ratio of the velocity in one medium with respect to the other is called the refractive index. So finding absolute refractive index, that is N, we usually use a symbol C by V. This is the equation. So here C is the velocity of light in air, that is 3 into 10 to the power of 8 meter per second, by the velocity of light in the given medium. For example, if it is 2 into 10 to the power of 8 meter per second. So, suppose the second medium has the light velocity 2 into 10 to the power of 8 meter per second. So in this case we know that it is 1.5. This will get cancelled, and the unit also same, since both the units are same, that also will get cancelled. So there is no unit for refractive index because it is a ratio between the same units. Okay, so the refractive index in this case is 1.5. So in such cases where one of the media, or we can say that the first medium is air, then it is called the absolute refractive index. Now what is the second one? That is called a relative refractive index. The relative refractive index is with respect to two media. For example, suppose here the light is going from one medium to another. Okay, so this is the first medium with refractive index 1. This is the second medium with refractive index 2. So where is the velocity changing? Is it in the first one or the second one? The second one, right? So we are going to find out the change in the second medium. So suppose this is V1, this is V2. Okay. N, or the refractive index, increases. That means optical density is increased, so velocity will be less. So we know that N is inversely proportional to velocity. So N is always 1 by V, or the reciprocal of velocity. So here if I am finding the refractive index of N2, okay, I have to find out the second medium only, because light is having a refraction in the second medium. So refractive index of medium 2 with respect to 1. Okay, see, so here we can say that it is N2 upon N1. So ratio of the refractive index of the second medium with respect to the first medium, because we are finding out for the second medium always, because it is entering into the second medium. So second medium with respect to first one is N2 by N1, or this can be also written as N2. We are supposed to find out refractive index of 2 with respect to 1. That can be written here. That also N2 upon N1. Clear? So these both the ways we can write. When you should know how to read it. N21 stands for refractive index of medium 2 with respect to medium 1. So medium 2 with respect to medium 1. Or if N1 to, if this way if we write, refractive index of medium 2 we are finding out with respect to 1. Again that formula is N2 by N1. There is a table in your textbook. In that the refractive index of crown glass is 1.52. Okay, and the refractive index of diamond is 2.42. Now if you want to find, so light is going from maybe crown glass to diamond, we know definitely what happens to the velocity, it decreases, right? Here the refractive index is increasing. But how will you find out? ND, diamond with respect to crown glass, or we can say NDCG for this I am writing. So what will you write? Refractive index of diamond by refractive index of crown glass, because we are finding out in diamond. So if you substitute, what will you get? 2.42 upon 1.52. So this is how you are calculating refractive index. Suppose if I am telling the light is going from diamond to a crown glass. So how will you write? Refractive index of crown glass with respect to diamond, then refractive index of crown glass we have to find out upon refractive index of diamond, from where it came. So in this case it is the opposite way, 1.52 upon 2.42. So this is how you will find out if two refractive indices are given. With respect to velocity, if you want to find out, it is slightly different. We know that refractive index is inversely proportional to velocity. So if it is going from medium 1 to medium 2, that is N1 by, we are finding out the refractive index of medium 2 with respect to medium 1. So then we have to see refractive index, velocity of medium 1 to velocity of medium 2, because velocity is reciprocal of refractive index. For example, suppose this is going from medium 1 to medium 2. Velocity is V1 upon V2. So how will you write? Refractive index of medium 2 with respect to medium 1 is equal to whatever we have to find out, that will come in the denominator, V2 upon V1. Okay, so always write what we have to find out. It is in the case of velocity, not in the case of refractive index given. If velocity is given, what we have to find out will come in the denominator. Or if it is going from medium, suppose this is water, this is glass, okay, so this is VW, this is VG. Now shall we write refractive index of glass with respect to water? So what should come in the denominator? This VG. Refractive velocity of light in glass upon velocity of light in water. Take the other way. Refractive index of water with respect to glass, because if it is going from glass to water, then what will happen? Velocity in glass upon velocity in water. So whatever we are finding out, refractive index of water, so velocity of that will be in the denominator. So this is how we will be doing the questions. We will try a question. Refractive index of a medium is 1.33. If the velocity of light in air is 3 into 10 to the power of 8 meter per second, find the velocity of light in the medium. So here one of the media is air. So we know that the formula can be N is equal to C upon V, because it is absolute refractive index. So C is the, N is given medium 1.33 is equal to C we know 3 into 10 to the power of 8 meter per second upon V. So we have to find out V. V is equal to 3 into 10 raised to 8 by 1.33. 2.26 into 10 to the power of 8 meter per second. Okay, so if one medium air is given, you can find out using this formula N is equal to C upon V. So let's see the next question. Refractive index of benzene is 1.5. So we can write NB is equal to 1.5 and that of diamond is 2.42. ND is equal to 2.42. What are we supposed to find out? The refractive index of benzene. So refractive index of benzene we have to find out with respect to diamond. So we know that refractive index of benzene by refractive index of diamond. We will do 1.5 upon 2.42. So 0.006 we will get, there is no unit. Now if it is the opposite way, we will find out refractive index of diamond with respect to benzene. So ND upon NB. So how will you write 2.42 upon 1.5? So we'll get 1.61. Velocity was given, then what we would have written? Refractive index of benzene with respect to that of diamond is equal to, so we have to find out benzene. So velocity of benzene will come down, so Vd. Whereas if we are writing with respect to refractive index itself, we will write Nb by Nd as we found out. The same way second one, refractive index of diamond with respect to benzene, then velocity of diamond will be in the denominator upon velocity of benzene, or if it is refractive index, we will write in the same order Nd by Nb. Okay, so this you have to always keep in mind. I am not adding numericals here, so I will make a separate. I have already posted physics numericals including the light numericals as well as the numericals from the electricity chapter, and also I have posted exclusively reflection numericals. Soon I will be posting 2 more sets of numericals, one from the chapter electricity and the second using the refractive index and the lens formula problems. If you like my videos, please share with your friends, and thank you for watching. Please don't forget to subscribe to my channel Biology My Passion.